what's due this week. Oh, before I forget, why don't you go ahead and go into week 2 lab and go ahead and put your name in there, because that's how I can tell that you participated and you have to get your 50 points, but I'd have to have something submitted there. While you're doing that, chapter 2 or chapter 1 review questions are due Sunday at midnight, and the breakdown of chapter quiz or chapter review questions are just answers only. And so, and from the text, just go to the end of the chapter, write down the answers, 1A, 2B, 3C, so on and so forth. Do it outside of Eagle, and then when you're ready to submit them, just submit them like that right there. You can basically just, copy and paste your answers into the submittal. It does give a text entry submittal box, so you just basically copy and paste your answers into the text message area. So, questions about review questions? All right, good. Next. Chapter 1 quiz, 14 questions. You get highest score out of three attempts, and it's open book, so just read the text and you should be fine. Questions on the quiz? Just make sure you have good internet connection, you've read the text, or you've got it next to you on a tablet or something where you can look up the answers if you need to and search them. And so that's one of the benefits of having a PDF, is be able to do that. So internet's pretty slow. Okay, research paper topic. Did we go over the list on research paper topic last week? Okay, cool. So there's a list at the top again. You can click on that read research paper topic, go to the bottom of that document, and there's, I believe, other that you can choose from as well. If you don't know some of the items in that list, which you probably won't know what they are, you can Google them. And the list topic is due, some of you have already submitted them, but the list topic is due Sunday at midnight. So if you have a question about what topic you'd like to choose that's not on the list, if it has anything to do with networking, you can come and talk to me and, say, hey, I'm thinking about doing this, and I'll let you know if that's good to do. Sound good? All right. We'll go back to, so you have review questions, quiz, and research paper topic. No class Monday, no class Tuesday, and we'll be back next Thursday with chapter 2. Tonight we're going to be doing, after the discussion, the lab is on the handout I gave you, and you'll be creating a fictitious company. I'll be giving you a fictitious company, and with a number of computers, servers, switches, and printers, and you'll figure out what all those are tonight. We'll talk about them. And you'll lay it out on a piece of paper. You'll get in groups and lay it on a piece of paper and decide how you're going to draw it out. Come up on the board and draw it up here, and that'll be the lab. So you'll kind of get to work in the group tonight. And what we'll probably do is these first 3 rows will be all one group. This row 1 will be a group, row 2 will be a group, row 3 in the back will be a group. And then over here, all 4 of you will be a group. We'll just do 4 groups like that. That'll work. Okay. So chapter 1 goes into the intro of networking, talks about what we're going to be doing tonight for the lab, on what a network is about, how it functions, some terminologies, how things relate to one another on a network. We're going to look at some advantages of networking versus standalone computing, which really in today's age, there's not much standalone computing. Even though you have a computer at home, maybe you have the only computer at home connected to a cable modem maybe, or a DSL modem. technically you're still part of the network of that cable modem or the network of that DSL modem. And so getting your ISP information through it. With mobile phones today, everyone's connected through that as well and connected to one another and your banks and all that good stuff. So networking, standalone computing term is kind of a misnomer anymore. They technically, yes, we have them, but they're really, probably if you look close enough, you don't have to look too far, they're fairly well connected to something or more than one thing as far as a network goes. Distinguish between what's called a client-server architecture, what a client is, what a server is, what peer-to-peer networks are. We'll talk about that. We'll look at some common elements between client and server architecture. And look at specific uses for networks. Certifications, we'll end on certifications tonight and what skills and specializations folks are looking for. You might have noticed the poster on the wall here and over here, and I talked about it already. I know a lot. It's on social media. But that RBC Tech Expo is the last part we're going to talk about tonight, which is finding a place to fit in technology. What is that place for you? You might not know yet. And that's part of what Tech Expo is about, is to get exposed to all different types of technology jobs, from programming to networking to network security to IT specializations like auditing a firm for software validation, making sure people have valid licensing on their computers at work, to IT management, to administration. So there'll be a whole bunch of different people on that night on the 25th of October. We even have a group coming out of Madison called G Beta that's looking for 10 to 12 to 20 to even more students to come to Beloit for 6 weeks, 1 day a week. And if you have an idea for a company, or you or a group of students have an idea for a company, they'll help you get your company off the ground with backing financially, tell you how to create an LLC and help you do it and write it and actually get it done, all for free for 6 weeks. Pretty awesome. What they've done is they have a bigger group in Wisconsin that people have to pay for 6 months, $5,000 to do the same thing. So they're condensing it to 6 weeks, but they're not going to charge students anything to do it. And so a lot of the speakers and helpers that help people do that will be there. So you'll hear about them and more as the time goes on. And I might even have the head of the company, the CEO, come talk to you guys between now and the end of the semester, come to the class and actually talk to you. And so and share with what they do. So anyway, certifications are important, but really anymore in college, I tell students, if you can get your foot in the door as an intern, that's going to be like gold on your resume. Really is. You really can't compare it to anything. It's really training that's hands-on. You get connected to some local employer, and a lot of times they'll hire students full-time at the end of the time of that internship. So if the student likes the company likes the student, there's generally a time at the end, hey, are you interested in maybe working here full-time? That type of conversation goes on. Brandon that I mentioned earlier, that's how he got hired full-time at Ebates and Fat Wallet, was same deal. He was an intern for 6 weeks. They liked everything he did so much, they offered him a full-time job, and he only had 1 semester of college under his belt. And so 6 months later, he pitched an idea for an app. Folks from California came, all the big wigs. They loved it so much. His app now replaced an app they'd been using for 10 years, and they upped him to senior programmer with only 2 semesters of college under his belt. And so internships are just, like I said, can't stress enough how important they are to get involved. And so I will tell you a lot about the ones I come across my desk. You'll see them on social media if you haven't already. I think I posted just today or yesterday 4 or 5 internship possibilities or actually current openings that you can get involved with. And so definitely get involved, both feet, and it'll be worth it definitely while you're here at college. So, all right, so why use a network? Good question, I'm glad you asked. Well, networks are a group of computers that are devices that connect together. That's a simplistic definition, but that's what it is. Group of computers, devices, we could say mobile, tablet, phones, laptops, desktops. A standalone computer is something that stands alone by itself, not connected to anything else. And so we could say probably your home computer. Say a laptop you might have connected to a Wi-Fi network, a desktop connected to a wired network connected to your modem, possibly. It uses local software and data on a standalone. Advantages of a network over a standalone are that you can share devices, not only share devices, but share data amongst one another, share programs amongst one another, and share resources amongst one another. If one computer on a network dies, that's okay, it still goes on. The network still functions. On a standalone computer network, or standalone computer type of scenario, if that computer dies, you got to get a new one. Until you do, you're dead in the water. And so on a network scenario, if a computer dies, we pull the plug on everything, either reinstall the software on that computer or put a new computer there, plug everything back in, and they're up and running. Most standalone computers have all the software and data all on that computer. Network computers store data on the network, on a server, not on a client, if it's important data anyway. On the client should only be stuff like software that should be installed to run and create programs. But data is stored on a network. That way, if that computer crashes and burns, again, worst case scenario, having to replace a computer, but let's say you just have to replace operating system and programs, which you can do all day long. But it's hard to replace data, and sometimes impossible to replace data if it's on that computer when it crashes. And so that's why it's important for shared resources. We'll find out. The other one is central network management. As an IT manager, I can centrally manage computers at Rock Valley, computers at Stenstrom, computers at Bell School campus, all from one location. I can do it from my phone, tablet, wherever, and push updates, control computers, help people that needs help, all from one location centrally. And with a standalone computer, you can't do that. There's different types of networks we'll find out, and we'll talk about some of the ones tonight. In fact, on the handout I gave you, there's 4 different types of layouts for networks that we'll go over tonight. And those network layouts have to do with where computers are positioned in the network, control levels over what shared resources they can see and can't see. An example would be this. Employees should not be able to see HR folders on the network that have to do with your personal data, right? That would be an example. Only those who need to see it should have access to that, which would be an HR in this case. Communication and resource sharing schemes are also can vary amongst networks. And then the different types of network models is peer-to-peer. A simplistic example would be if you brought your laptop up here and I connected my tablet to your laptop via wireless or Bluetooth or whatever, or a wired connection, that would be peer-to-peer. It's just me and you connected. That's it. And that's really a lot of times what IT does when they're going around to work on computers. They'll sometimes connect to that computer to run diagnostics, things of that nature. Same thing with servers. Peer-to-peer can also be your computer at home and my computer at home connected via a software, like a peer-to-peer type software, to where we can share files. You could say like Eagle is a peer-to-peer software, because within Eagle, I can send you a file and you can get it through email. But email, you say, well, that's email. Well, it's not, because it's really just a communication thing within Eagle, because it only works within Eagle. The email does. You can't send email outside of Eagle, and I can't send email into you from outside of Eagle. So it's an internal communication sharing. Also within Eagle, you can share data, but with the peer-to-peer software, you can share data, you can share resources, and it's definitely helpful. It's limited because it's peer-to-peer. You know, if my end gets disconnected on a peer-to-peer network and you're relying on data on my end to function, you're dead in the water, you can't function, and vice versa. And so peer-to-peers work for like hit and run data transfers. Some offices might have peer-to-peer because they're small enough to where it's maybe a boss and a secretary and that's it, and they can function just fine. But when computers get around 4 or 5 computers on a business or network or entity, it's best to jump on a networks type of layout, where you have a client and server type of architecture, which is the bottom. So peer-to-peer networks directly communicate to one another. They both have equal authority. Individual resource sharing, you can or cannot share resources. It depends upon the person that you're connected to, what you can see or can't see. The traditional model of peer-to-peer is 2 or more general purpose computers sending and receiving data one to another. And then again, that could be through Bluetooth, it could be through Wi-Fi, it could be through RFID. A number of different technologies could be used. Ethernet, which will create, actually, if you look at the back of the room, the white cables on the back of the room, here in a few weeks, you'll be creating both a Cat5 and a straight cable in the classroom. You'll come in on a Thursday. We won't do any discussion that night. We'll go right into cable creation because it's going to take the entire time to do it. So I don't want to pressure you to get it done. I will say, though, over the 18 years I've taught this class, 100% of the students have completed cable creation. And the oldest student I had was 86 years old that created a cable. And he started a brand new career, went back to school at the age of 75. And so a pretty cool guy. But anyway, he created the cable. So I have you guys put the cable around their neck when they're done and walk out, proud that he created it. It might be the last time you want to do it, but at least you've done it once. And you can say, I did it. But there is a career in cabling. And some of you might love it and do it and say, hey, it's good money in it. It's good money in running cables. So going back to peer-to-peer, 2 or more general purpose computers capable of sending and receiving data. Here's a screenshot of a peer-to-peer type of network. You'll notice everybody's the same on the same level. No one has authority over the other. But if, for instance, let's see, if this computer here gets X'd out and it crashes, and it has data that they need, then these files that are over here that might come from this computer are gone. And so that's a downside to peer-to-peer. The way I generally use peer-to-peer is a onesie type of connection to get data from somebody. Or if I'm working on a PC for diagnostic purposes, I can connect a laptop to that as well to find out what's going on and transfer files and things. Advantages of peer-to-peer, it's very simple to set up. All of your computers today, and have been for years, have an easy way to set up peer-to-peer. Literally, it's grabbing one of the red wires back there, even a white one would work, a straight or a cross cable. Could plug in your Ethernet port on your laptop or desktop to 2 computers, connect them together, and give them a moment to see each other, and you can start transferring files. That's how simple it is. It's less expensive because you don't have to buy switches and hubs, which we'll talk about. You don't have to buy routers. You don't have to buy file servers. You don't have to buy network operating systems, which we'll talk about. All that stuff you don't have to talk about. An average server cost for a business, a low-end server for a business of, say, 100 people, is going to cost you anywhere between $7 and $10 grand, the average cost. So it's expensive. It's not cheap. To buy a Windows server connected to a number of people. Once you buy all the software and all the hardware, it can be pretty expensive. And that's on the low end, what I just mentioned, 7 to 10 grand. That would be very, 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 very cheap type of setup. Disadvantage of peer-to-peer is it's not flexible. You can't grow with it. It's real difficult to grow. It's not necessarily secure because everybody has the same rights and on the same playing field. And it's not practical for large installations. It would be a nightmare for a large installation to have peer-to-peer. So resource sharing model is basically on a peer-to-peer where people can modify how they share things or what they share, but it's the user's responsibility to do that. If I want to share a folder with you, I have to right-click on the folder and say I want to share it with you. I have to do that. And if I don't do that, you can't see anything. It's not centrally controlled, meaning you have to go by each computer or touch each computer to make changes. And environments are well worked in as like your home, large networks that use the internet. You might have heard of some of these peer-to-peer softwares. Got Nella, Freenet, Napster, BitTorrent is probably the most recent popular one you've heard of. And BitTorrent's used by not only folks who want to illegally download and pirated software music, but is also used by big companies like Microsoft and Apple for folks to download files from their servers, because it does a good job of handling what's called bandwidth and load balancing that you'll learn about this semester when it comes to networks. And so client-server, let's talk about that. The client-server architecture is the most popular that you'll find when you work at any location, any business. Here on campus, we have client-server architecture. The computers you're in front of will be considered clients, and our servers actually for this room is located in the Cisco lab on the other side of the building here on the second floor. We're kind of off the grid on the campus because we do things that maybe would cause red flags on a network, just because we're teaching students how to set up networks, how to change networks, and so that would cause a lot of issues if we were hooked up to our network here at Rock Valley. But you've got to have a server when it comes to a client-server architecture, and it's what facilitates communication. It what helps you log in to the network. And here on campus, you log in with your S number and your password, right? And when you log in anywhere on campus, it goes to a central location in the IT office right as you leave the door here and take a left. Their server you log into is in that room right there, in that glass room. Same thing with Eagle. You authenticate wherever you are, from your phone, laptop, tablet, wherever you're at in the world. It's authenticated here on campus in a server room, in an actual server. Shared resources, the same deal. For Eagle, all locally centralized, located here, backed up in New York on a nightly basis. And then clients would be your computer, your laptop, your desktop, the one you're in front of. And it's also known as workstations. You might have worked in retail, maybe some of you, or sales. I worked in sales a lot going through school, like at Sears and places like that. And they have what's called a dummy hub, a dummy terminal. And they literally call it that. It's a monitor with a keyboard, a mouse, and a little black box. Right? No CD-ROM, no USB, none of that. And what it is you're literally getting your whole operating system, or what you see on your monitor, from a server maybe in that location, or in California maybe. And you're logging into that computer, and it's pushing a thin client to your device. And we'll talk about that this semester as well. But clients are personal computers, workstations. Central resource sharing is what's done by the server. So data sharing, like a database, like a SQL database, an Access database, or two popular databases. Data storage, a popular type of data storage device we'll talk about this semester is like a SANS device that's, terabytes or petaflops of data that are just, a boatload of data that can be stored on these. And devices can also be centrally managed. A big one today, you can imagine, is what's called BYOD, bring your own devices. Everybody brings their own device to work, right? And brings them on the field, and salespeople use them. And so IT departments have recently, in the last couple of years, a big type of company is those who manage mobile devices, can manage mobile devices, and have some type of way to network mobile devices, keep them secure, keep them from sharing data they shouldn't share. That's a huge move right now because everybody's going that way. No direct sharing, though, of client resources in a central resource type of scenario. The server is sharing everything. Nothing should be shared on the client side. Now, is it shared sometimes? Yeah. But should it be? No. If it's critical data, for sure it shouldn't. But I have seen where people don't share data or don't put data on the server. They're supposed to. Their computer crashes, and they go, I lost my data. And IT's response generally is, Well, we'll just back it up from, last night's backup. We'll restore it. And they go, oh, I haven't been storing it on the server. Well, not much we can do if it's not on the server. And so people are generally trained when they get hired a place, hey, store all important information on the server, but still human nature, sometimes people don't do it. And so we'll talk about ways to help folks educate people on how to store stuff on the server, the benefits of it. Because if you've ever lost data, which I know I have before, you get burned once, you don't want to do it again. And so, it's good to keep data in multiple places and keep it backed up. Let's talk about some computer roles on a network server architecture. We'll talk about servers and clients. Clients basically run local applications. Can somebody tell me a local application that you use all the time?
Firefox.
There you go, Firefox. Anybody else? No wrong answer.
Microsoft Office.
What? Microsoft Office. Thank you. You guys are really quiet tonight. Does anybody use a computer here? No, just kidding. So yeah, Office is huge, right? Browsers are huge. Any gamers in here? Anybody play games? All right, there you go. Give me a game you play maybe on a computer.
Diablo 2.
Diablo 2, there you go. Is there any Counter-Strike people in here still? Yes. Okay, that's good. There's hope then for the world. Anyway, so those are local apps, right, that you run. Now, all the ones you just mentioned definitely run locally, for sure. But in that app, let's talk about Counter-Strike for a second. If you don't play Counter-Strike, no big deal. But, in Counter-Strike, a lot of networking is happening, right? A lot of setting up a server, maybe another location, connecting to that server before the game starts. And so, things like ping, we'll talk about this semester, is involved in that. The faster, the lower the ping, the better for you. The higher the ping, you're dead. And so, with Microsoft Office, everything's moved in the cloud now. Everything's in the cloud. You literally, as students with Office 360, half of Office is now in the cloud, even though it's running locally. A little client is, most of it's running in the cloud. And so, will everything eventually go towards, well, yeah, it's going that way already, right? It's going that way already. Now in IT, it's kind of scary. I will tell you, in the last few years, there's been a lot of conversation on security or lack of security of data in the cloud. If I don't own it, I'm kind of leery of that. If I can't touch it in my location and back it up in my location, that can be kind of scary sometimes. Because even large companies like Google and Amazon is probably the largest cloud provider in the world right now. It is the largest cloud provider in the world of data, pure data. They do a great job, but I guarantee you, not to be a doomsday person, one day down the road, there will be a catastrophic crash or something's going to happen, and people are going to freak out. They're going to lose data, and money's going to get lost. Now, because of that, though, there thankfully are some solutions coming out to where you can still have an Amazon type of cloud, but also local backup that mirrors it constantly. That way, if Amazon ever does fail, which I think it will one day, anything's going to fail. That's technology related. You have a backup to push to and to pull your data from. Now, because of what I just said, IT folks like myself have been in the field for a long time. Folks that buy hardware are a little bit more at ease now that there's solutions out there that do that. And the reason I say that is you're starting your education or your walk in networking really at the prefaces of cloud computing. Everything you've been involved with and are going to be involved with is all surrounded around cloud, everything. But you'll hear more talk of companies providing local solutions as well to kind of back up that data. So it's important to have clients and servers and know what they are. But you'll notice on the third bullet point or fourth bullet point on our clients where it says that servers help you share applications, data, and devices. We have a number of apps here on campus that have certain licenses, right? So say an example would be, I was a graphic designer for years. We used a software program called Quark Express. You might have heard of one, maybe you guys might have heard of ones in graphics, maybe like InDesign. Anybody heard of InDesign before? Okay, InDesign is like the PC version of Quark Express. Quark Express used to be Mac only, but now it's Mac and PC. And now when InDesign came on the scene through Adobe, it was PC only initially. Now it's PC and Mac both. And I believe InDesign pretty much has the market share when it comes to graphics. But the reason I mention it is, if you guys are, if we're all graphic designers in here, right, and we have a license for 10 licenses, your client's going to run on your local, but as soon as you start InDesign, it looks to the server for how many is running. There's an app running on the server. When it reaches 10, that 11th person gets a message and says, you've exceeded your limit of 10 concurrent licenses. You have to wait for one to be open. Do you want to be notified? Something like that. And then you say yes, and you can be notified when somebody gets off of that license. So you have both in this scenario, a local client and something on the server checking to make sure you're running only the valid licenses that you purchased. It also can be used as using the server as an intermediary device, meaning I'm only going to use a server when I'm communicating in some scenario as a go-between. And so something to check for something. An example would be if I'm sending a file to you, a server app could be running in the background to check to make sure there's no viruses in that file, there's no malicious code or executables that could cause damage on your computer. That's an example. A piece of hardware that's popular, Barracuda is a popular hardware device that does just that. It's an intermediary device that filters everything that's going on in the network, every single thing, every bit of data going across it. And if it finds something like malicious activity or code, it can quarantine that computer's ports and literally shut down the network for that computer immediately and quarantine it from doing anything, which is a good thing. And so it can be used as just an intermediary device as well. Communication, we'll do on the board tonight when you do your drawing. Switches and routers. If you look at the back of the room, the case is actually open right there in the back of the room. There's about 12, 15 switches in that box there that's opened up, and all those blue cords running out are connected eventually to your computer that you're sitting in front of. And so there's a number on each one of your computers that corresponds with a number where that blue cord is plugged into the switch. And all a switch is a device to switch communication. You can look at it like that. If you're a computer and you have a wire connected to you and you're going to that device, and then from that device it's going to the server, all that's serving as is a switch from you to the server, from you to your friend, to you to your email server, so on and so forth. And it also, as a switch, connects everybody together in the room. So we can connect up to 25, 48 connections per switch, depending on the size of it. And then that allows everybody to communicate one to the other and share files and things of that nature. We use what's called a Cat5 cable. The little blue cable is a Cat5 cable that you'll be creating here in a few weeks. You can also use fiber. That's one that we use. In fact, fiber optic is used in here on the back of this box that goes into the underground, the floor into the IT office. This box up here is actually the PIX router for this room. It's hard to see from where you're at, but this little blue box here, this little gray box, it's a PIX router. What that serves for is getting all of us internet in here. And so there's going to be a few labs we do. I know in my 130 class that we throw that for a fit and lock it up, and I have to restart it because we basically hacked the web in here and we crashed the PIX router. But anyway, the PIX router is real important because it's the first line of defense coming into the network here, keeping us safe, and also going out as well. The PIX router, that little box, is configured with rules that can be uploaded, like a text file. And there's courses we have here on campus through Cisco that teaches how to set up a router, how to configure a router, also how to configure and set up a switch with rules as well. because switches have in them rules like what IP addresses they can go in and go out. Okay, PIX routers can have more rules like, okay, if somebody's coming in from the outside world into this room and we have a web server and they have a, say, a abc.com domain that they type in and it hits that PIX router, it's going to know to go to some local IP address in this room where the web server is located. Those rules all have to be set up in there. But I can also set up rules like saying, I'm going to block certain ports or certain services like FTP I don't want to be used in here, ping I don't want to be used in here. That can all be blocked on the PIX router side. We won't be doing any configuration of PIX routers in here or switches, but I do recommend, we will talk about them, but I do recommend taking Cisco courses that we have in Cisco 1 and 2, which goes over what I just mentioned. And it's definitely recommend. Much cheaper taking it here, by the way, than anywhere else in the world. The average 5-day course for Cisco configurations and admins about $5,000 for a boot camp, an 8 hour a day, 5 days a week for 5 days. It's pretty expensive. So ours is pretty cheap, and they're good instructors, and the information, the labs we use. They actually are using labs now to where you guys can remote in from your house and do your labs. It's pretty crazy. And so you don't even have to come on campus to do labs and stuff. So routers, switches are part of what IT does and networking does. The reason I said Cisco is, it's probably it is a predominant network provider when it comes to hardware. Now, you've probably heard in the news lately, the stock prices of Cisco went down. They're not making as many sales, and that is true. That's just because people aren't buying stuff. Companies aren't buying stuff. It doesn't mean they're not being used. They are. They just aren't buying new Cisco products right now. And that's generally the case on election year. People just don't buy stuff. Don't know what's going to happen, which makes sense. Next is a screenshot here of a kind of philosophically what a network looks like. Now, it would never actually physically look like this, but it's, a screenshot. You have on the upper left corner a workstation, lower left corner a printer, in the middle a switch. It's a connectivity device. It could also be a hub, which we'll talk about what that is. Bottom right, another client, upper right server. So in the middle, you'll notice all these black wires running to the connectivity device, and we'll say it's a switch. That's what allows all the devices to talk to one another, is that connectivity device. It actually does a switching on the device. It does a crossing of communication. And when we do the Cat5 and the straight cable, when we do the straight cable and crossover cable lab here in a few weeks, the straight cable, the wires are the same on both ends. Okay, the wires are exactly the same. There's 8 wires, and the colors are exactly put in the same on the connectors. On a crossover, 2 of the wires are switched. And on a crossover cable, you don't have to have a intermediate connectivity device to plug in to have 2 computers talk on a crossover cable. And those are the red cables in the back, by the way, the crossover. On a straight cable, though, you need a connectivity device because it does the switching for you of the 2 communication wires. So you'll notice on this example, clients can print to the printer, they can share files to the server and get files from the server. And that's a normal client-server architecture. Now, server requirements, most of you have installed or updated Windows stuff, right? Like Windows operating system, maybe. How many's installed Windows before on your computer, on a laptop, desktop, whatever? Everybody's done that, or you've seen somebody do it in your house or whatever. Servers have totally different operating system than your clients, like Windows XP, Windows 10, Windows 7, whatever you've got on your machine. It's called network operating system because it is a network operating system designed to function and manage other computers on the network. Generally, a network operating system has built into it capabilities to handle multiple clients connected to it. It can do authentication, meaning logging in, through a service called Active Directory. It controls user file access. It restricts user network access. I can go into the network operating system and say, with a little slider in the network panel, say, I only want people in here to access a network from 9 a.m. to 5 p.m., Anything outside of that, you can't get into the network. Easy. You can do that all on a network operating system. You can't do that on a client. On a client, you can't connect to other computers and have them authenticate to you as a client operating system. But in the network operating system, you can. It also dictates computer rules, meaning if I set up Active Directory correctly in a network operating system, I can say you guys are all like programmers in here, right? And you leave your shift, and the next people come in, and they're marketing people and log in the same computers. I can have them get access to things you can't see, and you get access to things they can't see, all with a simple login. It'll suck down the rules from Active Directory and say, you get to use this application, you get to see these files, you get to go to these websites, and that's it. Marketing comes in, they get a whole new subset of things that they can do, all from Active Directory. And so roaming profiles and being able to go to any computer on a network and do that can be dictated from a network operating system. And a client software can't do that. Client operating system can't do that. It also supplies applications to clients. You can push, I've already mentioned a couple in here, InDesign, Quark. Microsoft has a server-based application you can run. I've mentioned the thin clients, pushing data to those screens, like large companies do that, where they push entire applications to dummy monitors to push them. Most of your restaurants have that too, by the way. The register, somebody at Taco Bell or Pizza Hut or McDonald's, there's no big computer there. It's just a monitor and a touch screen, and everything's back in the server room being pushed to that client. And it's being pushed to the clients from the server. So here's some server examples of operating systems. Unix, Linux, Microsoft Server, all the way up actually to recent operating system, 2012, 2013, 2014, get ready to come out. 2018 is in beta stage. Mac OS server is the last one. So these are all servers. The most popular is definitely going to be Windows, definitely Linux, and the Mac OS. Those are the three most popular. Unix is still around, and it's used a lot for manufacturing servers that has a lot of machinery type of apparatuses that connect to a Unix server to function. So server features relative to clients, they definitely have more memory, okay? An example, a client might say have 12 gigs of memory, all right? Not uncommon for today's servers to have up to terabytes of memory, depending on the server that you've got. On average though, most servers, low end, have like 64 gigabytes, 128 gigabytes of memory, and that's low end of memory. Processors. Most of your computers, laptops, desktop have up at a quad 4 processor, right? But only one motherboard. Servers can have up to 32 motherboards. And each motherboard can have its memory connected to it, just like your computer at home. But they're all daisy-chained together for one server, one operating system, one network operating system. Storage capacity. They have what's called RAID hard drives, meaning I can have 10 to 12 hard drives in a server. One of them fails, I just take it out, hot swappable, put another one in, and without ever having to shut the server off. Can't do that in a client. And so it's equipped with special hardware, like I just mentioned, the hot swappable hard drives. They also have new on the block hot swappable fans, because servers, as you can imagine, are up all the time, right? They're literally running all the time. So fans do die. They get old. They get hot all the time, running. They fail. Well, they created a new technology for fans now to where there's 2 or 3 fans now on a server. If one fails, you can literally pull it out while it's running, plug another one in the spot, and without ever any downtime. Disadvantage, complex, as you can imagine, in design and even maintenance. Because when you have more parts, more processors, more memory, more hard drives, you're going to have more maintenance, right? And more money. And so, but in today's world, we pretty much can't survive without a client-server architecture. It's everywhere. So advantages relative to peer-to-peer, user credentials, sign in from one place on a server. And so multiple shared resources can be shared. from files to databases to programs. Central problem monitoring, diagnostic correction capabilities. User response time is up much greater on a client server than a peer-to-peer, because IT can tackle things much quicker because they know where things are at. Because you'll find out this semester we'll talk about monitoring tools, where from a monitoring tool I can see all my computers, all my servers, and if one's getting kind of weird and getting ready to crash or something, I can have it change the color from green to like yellow or red, and then know exactly where it's at in my location and send somebody there to pick it up and to fix it, or right click on it and restart it, all from a centralized area, centralized monitoring area. It's efficient processing on large networks because you can imagine all the memory it's got, the processing power it has, and it's continually running all the time, processing things. And it's scalable, meaning it can continually grow and add to the functionality of your server. It's popular in medium to large size organizations, anywhere from 20 and up, you'll find servers. Now let's talk about LANs. When I taught high school computer science and programming, we used what's called LAN parties. Anybody been to a LAN party before? Back then it was Counter-Strike was huge then, and thankfully it's still good today. People still play it. But one of the things I used to have my students do is I taught C++ programming that for this one class. They had to create different levels for Counter-Strike, different types of levels and areas that they had to go into, different maps, I think is what it was called. And they had to create a map with C++, and then if they created 3 maps, each one of them, I'd do a LAN party on a Saturday. They bring in their laptops, I bring in some switches, and I taught them little stuff like how to set up a small network, a LAN, and they were literally self-contained in a LAN, all connected one to the other, where very low latency, very, very fast network. And, what was funny about it was, you're in a room of 20, 30 high school boys, a few girls were in there, and, they had headsets on, because you have your teams of people you work with. Well, they're in the same room. Normally you play Counter-Strike if you're home or you're somebody across the town or world or whatever, but they're literally right beside each other. These guys are used to playing at home, right? Well, now they're in the lab right beside each other with the headphones on, and they're sitting there calling commands out. And I told this one guy, he was like, how did Joe find out about where we were going? I'm like, Joe's right there. He's right, you turn around, he's right there. But yeah, it was just so funny. He was watching, they had these headsets on, and they're still talking through the headset and the microphone, and the guy they're talking to might be 2 seats down. I'm like, he's right there, well, you just talked to him over. So anyway, it was kind of funny watching him. But LAN, the word LAN, local area network, really became popular in the 80s, where peer-to-peer was the only thing we had then. And so when LANs came out and we started creating small little LAN parties and LAN networks in our businesses. Today, though, it's much larger and complex. It's not constrained to one building or one room, but we'll talk about different types of LANs now that go across geographical, lines and oceans and, all across the world now. So LAN is very confined. The term LAN is local, meaning to say this room and this building would be considered a LAN. Everybody connected together, right? The next would be a metropolitan. This would be going beyond building boundaries. So we could say like this campus. So our building, CL12, Jacob's building, the arts, security, maintenance, all the building, PEC, would be considered a MAN type of network, a metropolitan area, meaning all these are connected now together, building by building. And you might ask, how are they connected? I'm glad you asked. You know how they're connected? Through tunnels. We have tunnels underneath all this building. It's about the size of a golf cart. A golf cart can fit through the tunnels, all the tunnels. And we have fiber optic that runs on the ceiling of the tunnels that connects all the buildings. And so I've not ever been given clearance to give students a tour, but I've always wanted to give my networking students a tour. And we have some new people on the block, so I'm going to try to get a sneak tour this semester for you guys. So keep fingers crossed. It's kind of cool. It's kind of messy down there, but it's a tunnel. But they do, there's guys that work in the tunnel, by the way, and they never leave the tunnel. So that's kind of scary. But anyway, and people are like, "There's a tunnel down there?" Yeah, there's a tunnel all over the campus here. So that would be like a metropolitan area network. And so here in the building, we're mainly connected in the classrooms with Cat5. From classroom to server room, it's fiber. From building to building, it's fiber. Okay, because fiber, you'll find out this semester, can run longer distances, right, without losing data. And it can run alongside electric, much more conducive than a Cat5, just because of the way fiber is created. The MAN connects clients and servers from multiple buildings. Generally what happens here, on the end of the tunnels, each building has a closet, type of maintenance closet, where it has a box where the fiber goes into the box, and then from that box, multiple fibers go floor to floor. And then from each floor comes in these little gray boxes pretty much throughout all the campuses. And then these gray boxes host switches that connect the classroom. Here's an example of a more complex type of network, client-server network. On the left is your server, clients, telephones, all connected on a LAN. You'll notice the router there with the lightning bolt and the cloud. It's considered what's called a WAN link, WAN. And anytime you have a WAN connection, you hear the word WAN connection, it deals with internet, all right? ISPs like Comcast, AT&T, Verizon. And you'll notice this WAN connection, in the very middle, there's a router that on the right side that is a larger network. We could say the one on the right maybe is a MAN type of network, like here on campus, okay, with multiple buildings. But notice one router's coming into both locations. You've got a router coming in here on this side and a router here in the middle, okay? And the router, as we mentioned earlier, is a first line of defense for the network, and so it keeps things safe and secure as much as it can with its rules that's been set in it. You'll notice also some of the connectivity devices are different on this one. Let's see if I can make this pin just a little bit bigger. Got a hub, switch. Let's see, on this side, it doesn't really, more like, doesn't even show one here, but we'll say it's a hub there. Switch. So let's talk about the two differences between switch and hub there. A hub is a dummy device. It's like first come, first serve, right? There's no rules in a hub. Okay, you can buy like a Linksys hub still today, like a 4-port Linksys hub, where it just has 4 Ethernet ports in it. First one, first serve, basically, on data. The switches, though, these guys are smart, meaning you set rules up in them, and you can even set up who gets the best service on that network. So you'd more than likely give a server some number one precedence of connectivity, maybe a few clients, and it can do what's called load balancing as well on switches, whereas hubs, again, can't do that. But hubs are still around, and hubs are cheaper than switches. A switch, those switches, each one of those Cisco switches went anywhere from $700 to $1,200, roughly around there. Hubs, you go buy at Best Buy and buy a 4-port hub, like a Linksys hub, about $40. But it works fine for home users. Awesome. But you don't need any more than that. WAN, anytime you hear WAN, remember internet. Internet, WAN, WAN, internet. And WANs have to do with this building connected to Stenstrom Center. This building connected to Bell School Center. All through a WAN connection. Okay? There are WAN connections that are connected directly, like a direct cable or line from the ISP to that other building. All right, like here in Rockford, it would be AT&T. We do have a direct line between us and other entities here in Rockford through AT&T. We also have where we just use our ISP to connect to other entities, which is much cheaper. Because you can imagine running a direct line is pretty expensive from building to building, across geographic. But it connects 2 or more geographic distances and connects LANs and MANs both together. All right? Comparison to a LAN, a slightly different transmission. Generally, you're going to be using this one. Satellite can be used in this one. Oceanic fiber can be used in this one. Ground fiber can be used in this one. Number of different types of communication, but those are the most popular. Network connection, separate offices in the same organization, like Pepsi. Pepsi has, I used to work for Pepsi, and they have their main office in Tulsa, Oklahoma. They literally have offices all over the world. McDonald's is another one. Coke's another one. All right? They have offices all over the world. Connected to, they have LANs in that location, MANs on multiple campuses, and then WANs will be where they're connected to their other offices around the world via an Wi-Fi internet connection. So here we have in the middle of this one 2 routers on both ends, the WAN link in the middle, and the WAN link serves as the the connection device basically. And this would be your ISP that you would buy it from. And so whatever the backbone that you're working off of. Here we're using what's called Illinois Network, centralized network here in campus. And it's in Springfield, Illinois, where we get all of our internet from here on campus. We have 4 T3 lines, which you'll learn about what that is this semester. Just say it's fast, but it's expensive. We literally hire a person every year to write a grant, because the last grant last year was $1.5 million for those connections. We have hired a person full-time that just writes grants to get funding for that connection. This is expensive. On the right side, you have a normal network of over here, some servers with switches. Over here, some clients with switches. You'll notice servers, I'll highlight these on this one. And servers are located, number of them in this location that they're just showing. And basically servers serve as not just authentication devices, but in a location, you normally only have one server that serves authentication device. The rest of them serve as file hosting places. Does that make sense? Where files are hosted. An example, you can have a server for authentication. You'll have a server for Microsoft Exchange. More than likely, most businesses have that. If they're a Microsoft Office company, which most are, that use Office. You'll have multiple other servers just for file repositories. So a lot of servers just for that. You might have a couple of servers for your web, intranet and intranet, both. So internal internet, web hosting, and external you could have as well. So a server can be either authentication, web, Exchange email, it could be an FTP server, could be a number of different types of servers, depending on what it is. But I will say this, servers generally serve one purpose, not multiple purposes, because it's too much. So it's just much more easier to manage if a server does one function, like authentication, Exchange server, file server, so on and so forth. So elements common to client server. On a client, the network computer requests resources or services. The client workstation has a human user. The client software is installed on a workstation. Server, the network computer is managing resources, and it runs a network operating system. So clients have a client operating system, networks have a network operating system. All right, similar. Workstation would be like your personal computer. That may or may not be connected. I would say today that would be the BYOD that we talked about that you'll hear a lot this semester. It's huge in networking now and IT. Bring your own device. Bring your own device management is huge, and it's I would probably say hundreds of companies within 150, 200-mile radius of Rockford, all dealing with supporting BYOD. That's all they do. That's what they specialize in. So that's a huge firm, or huge type of company, startup, that is big now. Some stuff we'll be doing this semester, you'll be playing with, NIC card. You'll be uninstalling and installing a NIC card, which is a network interface card that connects your computer to the network via a Cat5 cable. It is inside your computer. It connects you to the network and allows communication. Network Operating System, or NOS, is server software that enables authentication, data transfer, data storage, shared resource, and such. Here's an example of a NIC card on a slot on a motherboard, and you'll be seeing one of these up close and personal and uninstalling and reinstalling them. Very easy to do, and not uncommon for these to have to be replaced periodically on client computers. Say an example would be, say tonight we got a lightning storm and it hit this room. Even though all of these are connected to electrical that has fuses in them, I've even seen those get hit and fry a NIC card. So, and NIC cards are pretty cheap, so you'll do that this semester. Host computer just enables this resource sharing by other computers, and a host is also another term you'll hear for just server. A node could be a client, server, or other device. I even say the first node of every network, and I say this always on week 2, the first node of every network is a person. It really is. And at the end of the semester, I think in week 12, we do a troubleshooting lab where you get a chance to be a person that's taking calls from people that have some interesting problems. Some of these problems are computer related, but some of them aren't computer related. Some of them are maybe, they got let go or sent home for a few months because they were tampering with data. They come back and try to get back into IT on some networking resources and try to use flirtation and things like that to do it, and social engineering to do it. And so the first node of every computer is a person, unlike it says here. But then you also have clients, you have servers, you have mobile devices. And then the connectivity devices can be switches, hubs, routers, and we'll learn about all those this semester. Segment is a group of nodes together. So like we could say this room could be a segment of the network LAN here in the building. Backbone refers to what your network runs upon. In the building here, it's Cat5 from computer to switches. It's fiber from switch to switch. From building to building is fiber as well. And we could say from regional, geographical, from our location to Stenstrom, direct line. And in that case, T3, T1, direct line. We also used to have satellite connectivity where the nursing building's being built out now. They moved all of those satellites out near the end of Mulford Road, but we had about 20 satellites that connected point-to-point connections as well to local businesses and other educational places. Then lastly, topology. If you look at the first page on your handout, we're getting ready to get near to the lab here. Talks about 4 topologies on that very first page. Ring, bus, star, and hybrid. So we're going to talk about those, but look at the overhead there. The backbone refers to what the network runs on, and we could say in this case here, it might be all Cat5 as a backbone. So bus, star, ring, hybrid. The top left is the oldest in the ring or in the topologies. When we first came out on networks, this is what I used to work on, and it's coaxial cable, but it's just like your cable at home for your cable TV. That's what it is. And your NIC card had coaxial connectors to connect to that cable. just as fast as Ethernet today, but much more expensive to make, because you can imagine just to make a coaxial is much more expensive because of the sheathing, the covering, everything, much more expensive than a Cat5. Cat5 is really cheap to make. Then came on the scene a ring topology. Most of these had been used in banks and military facilities. A lot of computers in this one have 2 NIC cards, one for input, one for out. And you have redundancy on a ring topology. And what I mean by that is each computer, if I was sending data from this computer here to this computer here, as data is going across, it's copied to 2 computers in conjunction to that computer it's next to. And as it goes around the ring, it's duplicated to at least 2 other computers. When it finally reaches that destination, then that data is then deleted from those computers. That's how ring topology works. A lot of redundancy, but the data gets there. So that's why you find it a lot in banking and in military. New York Stock Exchange, ring topology. Okay, a lot of redundancy, but they have to have the data there. So that's why they have it. And it's much more expensive because of the multiple NIC cards. And back when coaxial was around, it was much more expensive because you'd have to run 2 coaxials per computer versus 1 coaxial. And so the top right is the current day. If you're a new business just starting out, building a business with a network, this is the type of network you're going to use. You'll buy a switch, server, some computers, printers, and you're in business. Okay? Much cheaper, by the way, than a ring topology. Much cheaper than even a bus topology. But the server on the upper right, the network topology there, uses mainly Cat5 connections and switches or hubs for the connectivities. The bottom right is most places in Rockford, or I could say anywhere in the U.S., that's 20 years old, company, 20 years old or older. You're going to walk into this because they've been around long enough to literally have coaxial. They've had coaxial with maybe some old networks. And yes, there's still companies that still have, in manufacturing that way anyway, have old servers and clients that still work and run for certain machinery maybe. Okay? So you can walk into places that have a hybrid of both old school and new school, both. Because it's cost effective, it still works on the old, why replace it? Will it eventually be replaced? Probably so. But right now, it might be the only thing that works. The old stuff might be the only thing that works with the machinery that they've got. Elements that are common, both the client server, you got protocols, data packets, addressing, and transmission media. Protocols will be like TCP/IP protocol, which we'll learn about this semester, that causes things to move upon the network with rules. Data packets are what it sounds like, data going from your computer to the network and from the network to your computer. Addressing, every computer has a unique IP address, just like your social security number. And to talk on the network, you have to have a unique IP address. And the server actually is the one who keeps track of all of that. And then transmission media is Wi-Fi, Cat5, fiber, just to name a few. Here's an example of coaxial, shielded twisted pair. That's what we'll be doing in the class, a middle one there. We'll be doing this one here. Fiber optic, much more expensive, but much more prevalent in manufacturing. Long distance runs, like between building and building. Radio waves is another one, direct point to point. An example here locally of a radio wave type of technology would be T6, you might have heard of. T6 is an internet provider that does point-to-point radio wave for internet provider for rural folks and things. And then I'm going to skip over here to some slides that I want to talk about or at least show before we get to the lab. So you can read this PDF I'll upload this week so you can read all of it. It's all from the text though. But let me get to some stuff that this is important, but Yeah, I want to get to the job market. Job market. A lot of jobs posted today. I mean, a lot of stuff. There's a lot of networking jobs out there. Networking tech admin, IT manager, just to name it 3 out of the hundreds of different titles you might have seen. Many job postings, many different expertise levels, from beginners like yourself to more advanced folks with years and certifications. But how to prepare, basically, like I said earlier tonight, is definitely internships in my mind, but certifications are good. And one of the ones that we do offer in this class is Network Plus certification. I can help you with that, give you some test software so you can plan on doing it. We can take it right here on campus at a lot cheaper rate than anywhere else. And they give you fail-safe, meaning you can fail it like once, take it again. But I'll give you software that you can train on it, get up to like 80% on the testing, and then take your test. And Network Plus is like a middle-of-the-road certification. It's not Microsoft, it's not Cisco. It's a Network Plus certification. It's a great certification, though. And you can hone your skills while you're in internship. Stay abreast of emerging technologies as well. Constantly having to go to training all the time in networking. Myself, 4 to 5 times a year to update, which isn't uncommon. So networking positions that utilize logical and analytical thinking can be also looked. So there might be some of you that are into numbers. You might be a person that does technical analysis of a network. You might be an analysis person. You just analyze things and you're good at that. You like doing that. And you're figuring problems out for people. And then you give it to maybe the programmer or the network admin to fix it. But you kind of are the go-between person that love to meet with people, organize things. You're good at logically breaking down tasks to find a solution. High demand types of positions. Consider general knowledge of all, specialize in a few. An example of that would be network managers are usually in high demand, high turnover, but high demand, with a lot of stress. IT techs, just general IT techs to do general IT networking, computer repair, computer installation, computer training, all in high demand, even now. And I would say probably more this year than last year. It keeps increasing. Also, one of the big fields in my mind would be network security is huge right now in all fields, both in networking, in mobile app development, and web development. Network security in all fashions and facets are a part of networking now, are huge. And then big one we'll talk about here at last is soft skills. Soft skills are not easily measurable, but important to network projects, meaning oral and written communication skills. Used to be in IT, everybody sit in a cubicle, nobody talked to anybody, and when you did talk to people, it just wasn't too nice. It just was like, just tell me when you're gone so I can fix it for you. All right. That's literally how it was 20 years ago, but you can't get by with that anymore today. People have to talk to people and be nice to people and, converse and, don't talk down to them. And so a lot of IT departments actually will send their folks to like Dale Carnegie School of Sales on how to talk to people, how to communicate. And so soft skills are huge today when it comes to networking. Now, you're still going to find people, though, in every business that are all technical, that don't leave the company too often. But that's good. We need those type of people. But not too often. It's not like the rule, it's the exception, if that makes sense. All right? What I mean by that is you might still have a guy that's awesome at configuring a switch, and he can do it so fast, but you would never put him on the phone with a customer to talk about buying a new switch. No, I'm not going to do that. Okay? Just not his skill set, right? Or her skill set. And so soft skills are important. I would say soft skills are getting more and more important as time goes on, right? than technical. Technical skills you can learn. Soft skills, some of you are born with really good soft skills. You're a people person, right? You love to talk, you don't have a problem with that. That's hard to teach people sometimes, it really is. Technical skills, though, are fairly easy. It's easier to teach technical skills to somebody than how to be a nice person, right? It just is easier. I don't know why. It just is easier, all right? So in IT, been a manager for a number of years. I've seen both people come in that have soft skills, not too great on technical, but those type of people I can really kind of work with more because I can send them to school. I can send them to school, training, a book, an online course, and they can get it, you know. They might not ever be up to, you know, expert level, but they can get stuff done, and I trust that. Because if you can make a person that you're working with in IT that's having a problem feel like you care about their problem and that you're working on their problem, that means a world to people. It really does. Versus, you know, well, you know, this happens literally every week, I think, doesn't it? Didn't you come to me last Monday? This is the third Monday now in a row. I think we've had the same problem. You know, versus, oh yeah, I can fix that. You know, and they're like, oh man, I'm sorry, I come to you every week like that. So that's what I get paid for. No big deal. Now, is there times in IT where you need to blow steam off? Oh yeah, but you do it outside of the purview of your customers. All right, and so you know, if people tell you that that's not right or that doesn't happen, it does happen. But you need to do it in the right area, in the right way, and definitely not in your cubicle, and definitely not in the lunchroom in your workplace. So anywhere besides that, yeah, probably. And don't email each other that, and don't text each other that. Do it in person, away from everybody else. That makes sense? And so we'll talk about that now. It's important to do that, and you need to do that. So